All right, get ready. We're going deep into intermediate Python.pdf today. Seems like you're ready to boost your Python skills. You've got the basics, but want more, huh? Ready to tackle some of the more powerful stuff.
It's pretty amazing how much this one document covers about intermediate Python. Really gives you a sense of what's out there once you're past the fundamentals.
For sure. That's what makes this deep dive perfect. We're going to look at everything from those tricky args and kwargs to the magic of generators and even those sneaky little things that can trip you up with those mutable data types.
It's not even just the syntax, though, right? It's about thinking like a real Pythonista, writing code that's elegant, that's efficient, that you can use again and again.
Okay, so let's jump right in. One of the first things this document hits on is args and kwargs. They can be kind of scary at first. Like, I remember when I first saw them, I was like, what are all these stars doing here?
Yeah, they can definitely throw you off.
Yeah.
But once you get them, they're so useful for making functions that are, well, flexible and adaptable. Instead of just having a set number of arguments, you can use args to pass in any number of those positional arguments as a tuple.
So if I wanted to write a function to, like, sum up a bunch of numbers, I could use args to round them all up.
Exactly. It's like having a function that can just stretch to fit however much data you throw at it. And then there's kwargs, which lets you work with any number of keyword arguments. And those get packaged up nicely as a dictionary inside your function.
So args for the positional ones and kwargs for those keyword arguments. Got it. But when would I actually use these things in a real project?
So think about this. You're building a website, and you need a function to make those HTML elements. Different elements will have different attributes, and you don't want to have to write a whole new function for every single one.
So I could use kwargs to pass in all those attributes, like as key value pairs, and then the function could build the HTML element based on whatever attributes I give it. That's pretty slick.
Exactly. And the document even mentions how understanding these args and kwargs is kind of like the foundation for even more advanced stuff like decorators. We'll get to those a bit later.
Oh, speaking of powerful code, the document then dives into debugging, specifically using PDB, Python's built-in debugger. Who has time for bugs, right?
Nobody wants to waste hours, right, hunting down those
Yeah.
annoying errors. What's really interesting about this section is that it's not just about fixing those bugs, but about really understanding how your code actually flows. It encourages you to, like, walk through your code line by line and watch how variables change and how the logic works.
It's like being a detective, right? Carefully examining the clues to figure out what happened. I remember when I first started using PDB, the N command, like the one that steps to the next line, that was a total game changer. And then C for continue for context. All those little commands give you so much control.
Exactly. And the document even mentions postmortem debugging. This lets you analyze a program after it crashes. It's like having a time machine for your code.
Okay, so PDB is our weapon against those nasty bugs. But what about when we want our code to run faster? More efficiently?
Well, that's where those generators come in. And this document, it does a really good job explaining not just how they work, but why they're so powerful. See, a lot of functions, they calculate all the results at once and store them in memory, which could be a problem when you're dealing with huge amounts of data.
That's probably why my computer freaks out when I'm working with, like, giant files.
Exactly. But generators are different. Instead of doing all the work up front, they make those values one by one and only when you need them. They even use the Fibonacci sequence as an example of the document.
Oh, the Fibonacci sequence. That's where each
Right.
number is, like the sum of the two before it, right?
That's the one. So if you were to calculate like a million Fibonacci numbers with a regular function, you would have to store all million numbers. But with a generator, it just calculates each number as you need it, saving you a ton of memory and making your code way more efficient.
It's like having a magic box that spits out numbers forever without taking up a lot of space. I'm starting to see why these generators are so cool. What else is in there?
Well, there are these two powerful functions called map and filter. They bring a touch of functional programming into Python.
Functional programming. Sounds kind of intimidating.
It might sound fancy, but it's really intuitive. With map, you can apply a function to every item in a list. Like, let's say you want to square all the numbers in a list.
I'd normally use a for loop for that. Go through the list, square each number, add it to a new list. That's a lot of typing.
Exactly. But with map, it's just one line. You give the squaring function the list, and map handles all the work. And then there's filter, which, well, filters elements in a list based on some condition.
Like a sieve that only lets certain things pass through. Gotcha. And then there are sets. They're all about making sure you only have unique elements, right?
Sets are like the bouncers of Python. No duplicates allowed. They're great for finding unique elements in a list or getting rid of duplicates. Plus, they can even be faster than using lists for some things.
So if I had a messy list all full of duplicates, I could just turn it into a set and bam, all the duplicates are gone.
Exactly. They also have these handy methods for things like unions, intersections, and differences, really useful for working with sets of data.
Okay, sets sound pretty useful for cleaning up my data. What else is on the menu?
Up next are ternary operators. Those little one-liners that can make your code super compact when you're working with, simple if-else statements.
Oh yeah, I've seen those before. They kind of look like shorthand if-else statements all crammed into one line.
That's a great way to put it. The document shows you how to use them for assigning a value based on a true or false condition, which can be super handy for making your code more concise and readable.
But I've also heard there's a less common way to use them with tuples. Something about that not being very Pythonic.
That's right. The tuple method is, well, a bit obscure. It can lead to some confusing code. It's usually better to stick with the regular if-else style for clarity.
Got it. I'll avoid the tuple method. So what other cool stuff is in there?
Well, it gets into the magic of decorators, which can seem a bit scary at first, but once you understand them, they're incredibly powerful. Basically, they let you change how a function behaves without actually changing the function's code directly.
So it's like giving my functions superpowers. I've seen examples of them used for like logging or authorization and stuff like that.
Exactly. Imagine you have a website and you want to make sure only authorized users can access certain functions. You could write a decorator that checks for authorization before the function runs.
So I wouldn't have to repeat that authorization code in every single function. I could just use the decorator and it would handle it for me. Pretty clever.
Exactly. And the document does a great job of explaining those decorators step by step, talking about nested functions, returning functions, passing functions as arguments. It all builds up to understanding how decorators work.
All right, so decorators are on my list of things to learn. What's next?
Well, then it gets into the concept of scope in Python, specifically the difference between using return to give back a value from a function and using the global keyword.
Scope. That's one of those things that takes a while to wrap your head around. It's all about knowing which variables you can access from where in your code, right?
Exactly. And the document really stresses how important it is to understand scope, especially when it comes to using that global keyword. Global variables might seem convenient, but they can make your code harder to manage, especially as it grows larger.
It's like having a really messy desk where you can't find anything because it's all just jumbled together. It's better to keep things organized and use return to pass values back from functions.
Exactly. It makes your code more modular and easier to understand. And speaking of things that can be a bit tricky, it then gets into one of the most common gotchas in Python, the difference between mutable and immutable data types.
Oh, those mutable data types. They can definitely trip you up if you're not careful. I remember the first time I ran into that issue with using a list as a default argument in a function. I thought I was making a new list every time, but I was actually just modifying the same list over and over again.
That's a classic mistake.
Yeah.
And the document does a really good job explaining why that happens and how to avoid it. It comes down to the fact that when you use a mutable object, like a list, as the default argument, Python makes that object just once when the function is defined.
So every time I called the function without giving it a list, it was just messing with that same original list. That explains so much.
Exactly. They recommend using none as the default argument instead, and then making a new list inside the function if the argument is none. That way, every time you call the function, you get a brand new list. No more weird side effects. So yeah, we were talking about making your own context managers. That's some pretty neat stuff. But hold on, this document's got more to share before we wrap things up.
I'm ready. What else is there to learn?
Well, there's this thing that can be kind of confusing. It's the for-else loop. You know how you can have an else with a try except block? Turns out you can have one with a for loop too.
A for-else loop? Really? I thought else was only for like if statements.
It's definitely a bit weird. The trick is the else only runs if the loop finishes without hitting a break statement.
So it's like a way to say, hey, I checked the whole loop and I didn't find what I was looking for.
Exactly. They even use the example of searching for a prime number. You loop through all the potential divisors, and if you find one, you break out of the loop.
Right.
Well, the else only runs if you get to the end of the loop without finding any divisors. That means the number is prime.
That makes sense. Like a signal that the loop did its thing without finding a match. That's cool. So what's next?
Well, it gets back to a function we all know, but one that can trip people up, the open function for handling those files.
Open. That one seems pretty simple. What's so hard about it?
It's one of those things that's like deceptively easy, you know? But there are a few things that can catch you off guard if you're not paying attention.
Like what?
Well, the big one is remembering to close the file when you're done with it. The document really stresses using the with statement for this. It makes sure that file gets closed, even if there's an error.
Right. The with statement, it's like insurance for file handling. Make sure everything gets cleaned up properly.
Exactly. It also reminds us about the different modes for opening files. Reading, writing, appending. If you use the wrong one, you might get some weird stuff happening.
And what about like binary versus text mode? That can be important, especially when you're working with files that have, characters outside of that standard ASCII set.
Absolutely. Encoding's super important, especially with international text or special characters. You want to avoid corrupting your data. The document even gives an example of checking if a file is a JPG image. They show you how to use binary mode and the with statement correctly.
It's like a condensed lesson in file handling best practices. Pretty handy. So where do we go from here?
Okay, so now we get to something I'm really passionate about. Making sure your Python code can work on both Python 2 and Python 3.
Yes. The classic Python version problem. It feels like every project I work on runs into this.
It's a common headache. But this document has some great tips for dealing with it. One of the most powerful tools is using something called future imports.
Future imports. It's kind of space-agey.
Well, think of them like time travelers. They bring features from Python 3 back to Python 2. So, for example, if you want to use the print function the way it works in Python 3, but you're stuck with Python 2, you can use a future import to make that happen.
It's like having a time machine for my code. I can use those new Python 3 features, even in an old Python 2 environment. That's really cool. Any other tips?
Yeah, it covers a few other things, like dealing with those module renames using try-except blocks and avoiding those built-in functions that got removed or changed in Python 3. It's all about making your code adaptable so it can handle those changes in Python.
So it's like learning to speak both dialects of Python. That way you can talk to any Python interpreter out there. What's up next?
All right, time to dive into something that can be a bit of a head-scratcher. We're talking about coroutines.
Coroutines. That rings a bell, but I'm not sure I really get what they are.
They're kind of like generators, but instead of making data, they take it in. It's a bit more advanced, but once you get it, it's super powerful stuff.
Okay, so generators are like data faucets, and these coroutines are like data sinks. How do you even send data to a coroutine?
You use the send method. The document has a really neat example where they make a coroutine that's like a mini grep command searching for patterns in lines of text.
So I could create a coroutine and feed it lines of text one by one, and it would tell me which lines match the pattern I'm looking for.
Exactly. And just like those generators, you have to prime a coroutine with next before you start sending it data.
It's like giving it a little kickstart. And then when you're done sending data, you can use the close method.
Yep. It's like saying, hey, coroutine, you've done your job. Time to shut down.
It sounds like coroutines would be perfect for like processing those streams of data, like parsing log files or reading from a network.
Definitely. They're really good for those asynchronous and event-driven systems. And speaking of making code more efficient, the document then gets into function caching.
Function caching. Sounds interesting. What's that all about?
It's a fantastic way to optimize your code. The idea is to store the results of those expensive function calls so that you don't have to keep recalculating them over and over. Like, imagine you have a function that takes a while to run, and you're calling it with the same arguments multiple times.
That would be a waste of time, right? Especially if those calculations are, like, really complex.
Exactly. That's where function caching comes in handy. It's basically giving those functions a memory. They remember the answer to a question they've already been asked.
So the first time you call the function with certain arguments, it saves the result. And if you call it again with the same arguments, it just grabs the answer from its memory instead of doing all that work again.
Exactly. And in Python 3.2 and later, they have this really neat decorator called lru-cache, which makes caching super easy.
lru-cache, what does that stand for?
It stands for least recently used cache. It's a smart way of managing the cache so that it always has the most recently used function results. Think of it like a library. They keep the most popular books on the shelves and put the less popular ones in storage.
Oh, I get it. So the least recently used stuff gets kicked out of the cache to make room if it gets too full. Pretty clever. What if I'm not using the latest Python, though? Do I still get to use this cool caching stuff?
You do. The document even shows how to make your own caching system using a dictionary if you're not using, the newest Python version.
Awesome. So even if I'm not on the cutting edge, I can still make my code faster.
Exactly. And to round things off, this document takes us back to those context managers. We talked about them before, but now we're going to get into how they really work and how flexible they can be.
Right. Those things with statement. I remember we talked about how they're good for like opening files, but I'm ready to learn more about what's happening behind the scenes.
Well, get ready, because they're more powerful than you might think. You're probably used to using them for opening files, but you can actually make your own context managers to handle all sorts of setup and cleanup tasks.
Wait, so I can make a context manager to like connect to a database, do some work, and then make sure it disconnects properly all automatically.
You got it. The document explained how you can make them. Using classes, they have these special methods called enter and exit. The enter method takes care of the setup, and exit handles the cleanup.
It's like having a built-in setup and cleanup crew for your code.
Perfect analogy. And that exit method, it even gets information about any errors that might have happened, so you can handle them gracefully during cleanup.
So it's not just about cleaning up after yourself, it's about handling those errors too.
Precisely. And if making a whole class seems like too much work, there's a shorter way. The document shows how you can use a decorator called context manager from the context lib module.
So you can make a context manager with like just a function and a decorator. That sounds a lot easier.
It's a great option for those simpler context managers. And you know what? That's it. That's everything this awesome document covers.
Wow. We covered a lot of ground from the basics of args and kwargs all the way to those more advanced things like coroutines and making our own context managers.
It's a real treasure chest of knowledge. You got all the tools you need to really level up your Python skills.
My Python toolbox feels full to bursting.
And hey, remember, this is just the beginning. There's always more to learn.
There's always something new to discover in the world of Python.
So keep exploring, keep trying new things, and keep pushing the limits of what you can do with Python.
And to our listener out there, thank you so much for joining us on this deep dive into intermediate Python.
We hope you've enjoyed it and learned a ton.
Keep on coding, keep creating amazing things, and keep sharing your passion with the world. Until next time, happy coding.
So we were just diving deep into those custom context managers. Super useful stuff.
Yeah.
But you know what? This document, it's like a gift that keeps on giving. There are a few more things to unpack before we call it a day.
Oh, I'm ready for more Python goodness. What else is there?
Well, they bring up something that can be a bit of a head-scratcher for some folks. It's the for-else loop. Like how you can have an else block with a try-except statement. It turns out you could do the same thing with a for loop.
Wait, a for-else loop? That just sounds wrong. I thought else was only for those, like, if statements and conditionals.
It definitely seems a bit odd at first, right? The key here is that the else block, it only runs if the loop finishes naturally, like without hitting a break statement along the way.
So it's like saying, hey, I looked through the whole loop and I didn't find what I was looking for. Is that it?
Exactly. And they have a good example in here using prime numbers. You could loop through all the potential divisors, and if you find one, boom, you break out of the loop. The else only runs if you make it all the way through the loop without finding a single divisor, meaning the number is prime.
Oh, I see. It's like a special signal that tells you the loop ran its course without finding a match. Pretty clever. What else is there?
Well, they circle back to a function that everyone uses, but that can sometimes cause a bit of trouble. It's the open function for handling those files.
Open? That one seems pretty basic. What's so tricky about it?
It's one of those things that can sneak up on you, It looks simple enough, but there's some little details that can trip you up if you're not paying close attention.
Like what? Give me an example.
Well, first and foremost, always remember to close that file when you're done with it. The document really hammers this home, saying you should use the with statement for this. That way, even if there's an error, the file will get closed properly.
Right, the with statement, it's like a safety net for file handling, ensuring everything gets cleaned up no matter what.
You got it. They also remind us about those different modes for opening files, like reading mode, writing mode, appending mode. If you use the wrong one, well, let's just say you might not get the results you expect.
Oh, and what about that whole binary versus text mode thing? That can be important too, right? Especially when you're dealing with files that have characters outside of that standard ASCII set.
Absolutely. Encoding is crucial, especially if you're working with, international text or special symbols. You don't want to end up with corrupted data. They even give a nice example of checking if a file is a GPG image, showing you how to use binary mode and with statement correctly.
It's like a condensed guide to best practices for working with files. Really helpful stuff. So what's next?
Okay, now for something near and dear to my heart. We're going to talk about writing Python code that can run on both Python 2 and Python 3.
Ah, yes. The age-old Python version compatibility challenge. It feels like every project I work on has to deal with this at some point.
It's a common problem for sure.
Uh,
But this document has some smart advice for tackling it. One of the best tools in our arsenal is something called future imports.
Future imports. That sounds pretty high-tech.
Think of them like time machines for your code. They let you use features from Python 3 in your Python 2 code. So let's say you want to use the print function the way it works in Python 3, but you're stuck using Python 2 for some reason. Well, with a future import, you can do just that.
Wow, so I can use those newer Python 3 features even in an older Python 2 environment. That's pretty amazing. Any other tips for making my code work across versions?
Yep. They cover some other strategies too, like using try-except blocks to handle those module renames, and being careful not to use any built-in functions that got removed or changed in Python 3. It's all about making your code adaptable and future-proof.
It's like learning how to speak both dialects of Python fluently. That way you can communicate with any Python interpreter out there. What else do they cover?
All right, now get ready for something that can be a bit mind-bending: coroutines.
Coroutines. I've heard that word thrown around, but I'm not entirely sure what they are.
Okay, think of them like generators. But instead of producing data, they're designed to consume it. It's a bit more advanced, I'll admit, but once you wrap your head around it, it's a very powerful technique.
So generators are data faucets and coroutines are data sinks. Am I getting that right? But how do you even feed data to a coroutine? Do you just pour it in?
You use a method called send. They have a really nice example where they build a coroutine that's like a mini version of the grep command. You know, the one that searches for patterns in text.
Oh, yeah. So I could create a coroutine, feed it lines of text one by one, and it would tell me which lines match the pattern I'm looking for.
Exactly. And just like with generators, you have to kind of prime the coroutine first using next before you can start sending it data.
It's like giving it a little nudge to get it started. And if I want to signal that I'm done sending data, I can use close.
Right. It's basically saying, hey, coroutine, you've processed all the data. You can take a break now.
Coroutines sound like they would be really useful for things like parsing log files or reading data from a network connection. Anything where you're dealing with streams of data coming in.
They're definitely great for that kind of stuff. They're really good for those asynchronous, event-driven systems. And hey, while we're on the topic of making code more efficient, this document also talks about function caching.
Function caching. That sounds intriguing. What's that all about?
It's a really clever way to optimize your code. The basic idea is to store the results of those function calls that take a while to compute, so you don't have to recalculate them every time.
So if a function gets called with the same arguments multiple times, it can just grab the answer from its memory instead of redoing all the calculations.
Precisely. And in Python 3.2 and later, there's this awesome decorator called olrecache that makes setting up caching super easy.
Olrecache, huh? What does that stand for?
It stands for least recently used cache. It's a clever way of managing the cache so that it's always holding on to the most recently used function results. Think of it like a library. They keep the most popular books on the shelves, ready to go, and they put the less popular ones in storage.
Ah, that makes sense. So the least recently used stuff gets kicked out of the cache if it gets too full. Very cool. But what if I'm using an older version of Python? Do I still get to play with this caching magic?
You do. The document even shows you how to make your own custom caching system using a plain old dictionary.
So I can still benefit from caching even if I'm not using the latest and greatest Python. Awesome.
Exactly. And, believe it or not, that brings us to the end of our deep dive into intermediatepython.pdf.
Wow, we covered so much, from the basics of args and kwargs to those more advanced topics like coroutines and even making our own context managers.
This document was packed with useful information. It's given us all the tools we need to really step up our Python game.
My Python toolbox is overflowing now.
And remember, the learning never stops. There's always something new to explore in the world of Python.
So true. There's always more to discover and more to learn.
So keep experimenting, keep pushing those boundaries, and see what amazing things you can create with this incredible language.
And to you, our listener, a huge thank you for joining us on this incredible journey through intermediate Python.
We hope you enjoyed it as much as we did, and that you're walking away with a ton of new knowledge and inspiration.
Keep coding, keep creating, and keep sharing your passion with the world. Until next time, happy coding.